You know, we use them literally every single day. For work, for fun, for staying connected. They're on our desks, in our laps, even in our pockets. But have you ever stopped to ask, what exactly is a computer? Well, let's unlock that black box and find out.
No, I mean, really think about it for a second. If you look past the screen and the keyboard, what is this thing fundamentally doing? It can seem like total magic, right? But it's actually all built on a beautifully simple idea.
So, at its very core, this is the big idea. A computer is really just a tool. It takes something you give it, that's the input, it does something with it, that's the process, and then it gives you back a result, that's the output. Honestly, every single thing a computer does, from playing a movie to sending an email, is just a version of this.
Yeah, this whole process is so fundamental that you could pretty much forget the word computer and just call it a data processor. That's its entire job. It takes raw data, like say the sound waves from my voice right now, and it processes them into something useful, like the audio you're hearing in your headphones.
And here's that loop in action. You feed it some raw data as input. Maybe it's not just numbers, but a huge, complicated set of weather patterns. The computer then gets to work, it processes that data, running all kinds of calculations and simulations. And what comes out the other side? Output. Useful information like a forecast for the next week. It's that simple cycle over and over again.
Okay, so if it's just this simple three-step process, what's the big deal? Why is it so revolutionary? Well, it's all about how it does that process. Let's get into the machine's superpowers.
First up, speed. And I mean mind-bogglingly fast. A computer can do an amount of work in just a few seconds that might take you or me an entire year to get through.
So to put that speed into perspective, check out this number. That's billions. A powerful computer can perform billions of simple calculations every single second. That's more math in the blink of an eye than you could possibly count in your entire lifetime. It's just incredible. And here's the other thing. Unlike us humans, a computer never gets bored. It is the very definition of diligent. It can do the 10 millionth calculation with the exact same speed and precision as the first one. It doesn't get tired, it never needs a coffee break, and its concentration is perfect.
You know, all these superpowers really work together. A computer is incredibly accurate. When errors happen, it's almost always because of what we put in. Programmers have a saying for it: garbage in, garbage out. It's also super versatile, right? It can jump from playing a high-def video to sorting a massive spreadsheet in an instant. And all of this is backed up by a perfect memory that can recall huge amounts of information flawlessly.
But, and this is a really crucial point, for all that power, a computer has an IQ of 0. It has no actual intelligence, no feelings, and it cannot make a single decision on its own. It only does what we, the humans, tell it to do. It's an unbelievably powerful tool, but we're the ones providing the instructions and the brain power.
So, once we figured out these characteristics, we started building all sorts of different computers, basically packaging these superpowers for all kinds of different jobs.
You can think of it like this. An old-school mercury thermometer is kind of like an analog computer. It measures a continuous, smooth change in temperature. On the other hand, almost every computer we use today is digital. It processes everything as separate on or off signals. Yep, the famous ones and zeros. Hybrid computers, which do a bit of both, are pretty specialized. You find them in places like hospitals or factories. And we also sort computers by their sheer size and power. Most of us use a microcomputer. That's your PC or your laptop. But from there, they get way bigger. You've got mini computers, then huge mainframes that are still the backbone for banks and airlines. And then at the very top, you have the supercomputers, the absolute giants of the industry, tackling enormous problems like climate modeling or mapping the human genome.
So, how did we get from those giant room-sized calculators to the little devices we have today? Well, it all happened in 5 distinct stages, or what we call generations.
Each one of these generations was defined by a huge technological leap. We started with these massive, clunky, and pretty unreliable vacuum tubes. Then, those gave way to the much smaller and more dependable transistor. After that came the integrated circuit, which packed a bunch of transistors onto a single chip. The microprocessor took that even further, putting the entire brain of the computer on one chip. And today's 5th generation? It uses something called ultra-large-scale integration, which crams billions of components into a space smaller than a postage stamp.
The scale of this journey is just staggering. I mean, think about it. We went from first-gen machines that filled an entire air-conditioned room and needed the power of a small town to these 5th-gen devices of unbelievable power that now fit right in our pockets. Wow.
All right, so now that we've seen where they come from, let's finally peek inside that black box and look at the basic hardware that makes that simple input-process-output cycle actually work.
At the most basic level, a computer is really just these four key parts. You've got your input devices, like a mouse or a keyboard, to get data in. You've got output devices, like a monitor or printer, to see the results. Memory is the temporary workspace, and the CPU, well, that's where all the real magic happens.
And yeah, that place where all the heavy lifting gets done, that's the star of the show. The CPU, the central processing unit. This thing is the engine, the brain of the entire operation.
And the CPU itself is split into two main jobs. You've got the arithmetic and logic unit, or ALU. That's the calculator part. It does all the math and makes logical comparisons, like is this number bigger than that one? Then you've got the control unit. Think of it as the traffic cop. It directs the flow of data and tells all the other parts of the computer what to do and when to do it.
So let's trace that path one last time. An input device, like your keyboard, accepts data. That data zips over to the CPU and memory, which work together to process and store it. And finally, the result is sent to an output device, like your screen. And just like that, the physical parts bring our simple input-process-output cycle to life.
And there we have it. We've come full circle, right back to that fundamental idea. Data goes in, it gets processed, and useful information comes out.
You know, it's such a simple loop, but in just a few decades, it has completely reshaped our world. The real question is, as this cycle gets faster and smaller and even more powerful, what will it create next?